Bismillahirrahmanirrahim. So, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hilman Bisham, and I will be talking about the introduction for our PBL, which is the digital clock. So, firstly, the usage of clocks is widespread throughout the world. Knowing how to tell time accurately in a certain time zone is a need in life. For a normal digital clock, 1 hour is divided into 60 minutes, 1 minute into 60 seconds, and 1 day is divided into 24 hours. We have decided to construct the digital clock as our project for Task B. This project involves creating a unique digital clock that can track time every day. The digital clock was chosen over the analog clock because it has more functions and is much more suited to be used with the Easy68K software. Additionally, reading the time does not require any particular training because digital clocks are simpler to read than analog clocks. Thank you very much. That is all from me.
So next, we go to the objective. So for the first objective of this project is to be able to use the MC68K assembly program to design a digital clock system. The objective is to particularly build the digital clock so that it can display the hours, minutes and the seconds on the 7-segment display by using the knowledge of using the Easy68K learned in microprocessor lesson. So for the next objective is to be able to list both the programs input to the IDE 68K and its output following execution. The output of the digital clock program should be able to accurately display the time in accordance with the time that was set up on the computer, indicating whether or not the program's objective have been achieved.
Hi, I am Abdurazak. I'm going to explain flowchart for the setup the display time of digital clock. So take a look at the left side of the flowchart here. Firstly, we start and receive input command line. If the command is not valid, we keep receive the input command until it become valid. When the command become valid, we go to the first subroutine, which is set up for the display on 7 segment. We take a look here, the flowchart for the first subroutine. We start and in hexadecimal form, initialize the pattern of the digit. We map the pattern of the time, then set up all the digits to minus sign. Then we reset all the digits to hexa A, then return back to the second subroutine here, which is the setup for the time. Here, the second subroutine we started, then change the time from the 30 second to second, divide the second up into the value of each digit, then extract the next digit value from the time. Then we compare each of the digit. If there any difference, yes, we change the digit and we start again. And if there is no any different, then we look back from the start. Then we display the time. So we only need to run once for the first subroutine here because it's just to initialize and set up for the display. And for the second subroutine, flowchart here, which is the non-stop, because this process allows us to update our time. Now, move to the next flowchart. Now, I want to explain the flowchart for the time. So we start display on screen and then display the second. And take a look at the subroutine here. Display the second, increase the second by +1, and then display the second. And then return to the flowchart. And we make a decision either the second is 60 seconds or not. If it's not, we display second, increase the second by +1, and then display the seconds again. Until it becomes 60 seconds, then move to the next, clear the seconds to 0. And then we move to the display minutes. And take a look at the second subroutine here. Display minutes, increase the minutes by +1, and then display the minutes. Then return back to the flowchart, and we make a decision again. Is it the minutes is 60 minutes or not? If it's not, then we back to the subroutine, display minutes, increase the minute by +1, display the minutes, and then returns. If it becomes the 60 minutes, then we clear the minutes to 0, and then we display hours. Take a look at subroutine here, display hours, increase the hours by +1, display the hours, and then return back to the flowchart. Then we make a decision again. Is it the hour that is 24 or not? If it's not, then we display hours, increase the hours by +1, display the hours, and then return back to the flowchart. If it's become 24 hours, then we clear the hours to become 0. And then we start again to do this second.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Shukri bin Ahmad Adnan. I will explain about recording for our digital clock in Easy68K software. First, I would like to run the program. Here we can see that this is the hardware for our digital clock. First thing first, we are set up the display here. We use time setup. This is the define constant dot byte $000. That means first place in our 7 segment display. After that, we use define constant dot byte $002, which means second place. Follow on with 004, 06, 08, 10, 0C, and 0E. As we can see here, we purposely left the 04 place and 10 place empty because we need the gap for hours, minute, and hour second. After that, we define the time character. We use the define constant byte $3F. 3F means 1 for in binary code, but we use in hexadecimal. Following with 06, 2 means 2, 5B, 3, and so on. We continue our process with setting the digit to 0A to make it always added to the time digit. The main system start from time main, time display, and time digit. These 3 subroutine will be in loop so that our time will be constantly add as it resemble a clock. Here I will show you the result. As we can see here, the time is the same with our computer clock. Okay, that's all from me. Thank you.